Greetings, welcome to the Old Ways Rising Farm YouTube channel. This is another video filmed in December where we're actually going to be talking about growing things. We're going to be specifically growing some mushrooms. The purpose of this is to show you how to take store-purchased mushrooms sold for eating and propagate these so that you can then grow your own batch of mushrooms. This is incredibly easy to do if you understand a couple things about the biology of fungi and mushrooms in specific. So, warning, this does contain some scientific content. The first thing that we need to do is we need to be very, very clean. Now, we don't have to be 100% sterile to have this be successful at least the majority of the time. It won't be successful 100% of the time, but it will be successful the majority of the time as long as we are clean and as clean as possible. You don't need clean room, 100% dust-free, 100% sterile autoclaved equipment because of a trick that I'm going to show you. We do, however, need to have things largely disinfected, as dust-free as possible, as clean as you can get them. But as you can see, we are just in our kitchen. We're going to keep this contained at the table because I've been doing a lot of wood carving right over there, and we're not going to show you that mess today. So you can just do this in your home. It's not a big deal, but we do have to take a couple precautions. First, wipe everything down. Fairly obvious. Keep everything clean. Have a set of materials specific to every mushroom that you're going to cultivate. So I am doing 3 today. To show you the end result, we're going to be growing cardboard cultures. This is what you're going to end with at the end, at the completion of your activity. These are maitake mushrooms. Did those about 15 minutes ago. I have multiple cutting boards. I'm doing 3 species. I had 3 cutting boards. 1 is already placed back in the sink. I have a unique cutting board, a unique knife for every species. I'm going to keep them separate. Second, cardboard is our growing medium. We'll talk about growing mediums here in a minute. We want to pasteurize the cardboard. Pasteurization is not the same as sterilization. Pasteurization, you have a rapid temperature change for a short duration of time, which kills the majority of bacteria and fungi present on the material that you're working with. It will not kill spores. You are not going to get rid of bacillus spores. You are not going to even get rid of most fungal spores. But you will drastically reduce the quantity, ouch, that is hot, the quantity of living, actively growing material on your medium. This is important to do. So we're going to pour boiling water on top of our cardboard. So we'll also make our cardboard fall apart, which is important. We'll get to that in a sec. Now, while that's there and cooling, we're going to pull out a clean cutting board. We're going to pull out a clean knife. Simple steak knife is fine. Nothing fancy here. Set that over there so I don't burn my fingers again. And let's look at the mushrooms themselves for a minute. The mushroom that you eat is the fruiting body of the fungus, much like the apple on the apple tree. The actual structure of the fungus is called hyphae or mycelium, depending on what stage of its life cycle it's in. These are long microscopic threads that occupy the growing medium. These can be literally square miles in size in nature. Okay, the largest and oldest organism is a honey mushroom out in the Pacific Northwest. I forget whether it's Washington or Oregon, but it is many square miles in size, and genetic testing has been shown that this is all one organism. It is probably 10,000 years old. These are the real grandfathers of the forest. Okay? What we eat is the fruiting body, the apple on the apple tree. These are blue oysters. But the actual organism is that long series of threads. When you have threads in the mycelium growth stage that experience the proper conditions to spur fruiting, they start to twist up and form nodules called sclerotia, and then those nodules expand into the fruiting body. But it is still just these threads twisted together. So the whole mushroom fruity body is just a twisted network of these knotted threads, the threads being the large organism. At the end of the fruiting body, the mycelium, which has the full complement of DNA, undergoes meiosis with a couple of extra quirks unique to the fungal kingdom, producing spores. Those spores have half of the genetic complement. Those spores are produced in this gill tissue. Those spores are released in the wild. They germinate directly into an organism which also only has half of the genetic structure, called hyphae. Hyphae are, again, thread-like. They expand. When two hyphae of compatible mating types, these don't have a binary sexual differentiation at all. They can have 20, 30, or more mating types, which are indicated by long strings of pluses and minuses. Plus, plus, minus, minus, plus, plus, plus can mate with plus, 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 minus, 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 but not minus, 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 plus, 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 right? It's complicated. But when two hyphae of compatible mating type touch, they fuse, become a polynucleated organism, which then is now called mycelium, which will grow, expand, and eventually produce another fruiting body, completing the life cycle. That's the life cycle in nature. The interesting thing about these mycelial networks is that they can be cleaved and rejoined very readily. Okay, so what I described with spores is the sexual mode of reproduction. They can also reproduce asexually by cutting the hyphae, and then you would now have two, wherever they were cut, wounded, they will grow out from those points and reoccupy the growing medium, whatever that is, whether it's a dead tree or leaves in your garden, or in our case, these wonderful little patties of cardboard that I need to flip so that they get fully soaked. And if they meet each other, they can refuse into a single organism. If they are cleaved, they can again go off on their own. So when we are growing mushroom spawn with the eventual goal of inoculating some tree branches, we want the asexual mode of reproduction. We're taking cuttings, we are not growing spores. So the part of the fungus that we're interested in is the stipe. This unit here, not the cap with the spores. These have already differentiated. They've started to undergo their slightly extra complicated version of meiosis, and it's more difficult for this region to return to growing a mycelial network. They're pretty committed just to producing spores. However, if you look at the base of this one, it may or may not, we are filming this with a simple, we are filming this with a simple cell phone camera. Okay, I apologize, we had a momentary problem with our technology. We'll splice this together after the fact, so if there's a little bit of choppiness, I apologize. Again, if you come in here, if you can zoom in there, and there's a little bit on this one as well. I'm not sure how well it will pick up because it's a very fine structure. But right on the surface here and right in the cleft between those two stipes, you can see a little bit of fuzziness. At least when you're looking at it with the eye, you can see a little bit of fuzziness. That's not mold growth. That is the mycelium, which are twisted together into this stipe, recognizing that they've been cut from their source of nutrition, trying to reach out and find another one. So these are, those little hairs are little ends of the mycelial net forming this structure, desperately trying to find something to eat. And we're about to give them that, okay? So for doing this, this is always a race between the fungi you want to grow and the fungi you don't want to grow. So we want to do everything we can to make sure that it's the oysters. See right here, those are some little sclerotia that failed to produce a full fruiting body. So we want to make sure that we do everything we can that one's very fuzzy. Very good, very good. To make sure that the oyster mushrooms, which we want to grow, can outgrow their competition. So to do that, we're only going to cut off the pieces that are most likely to reestablish growth when we put them on the cardboard. The rest of this is tomorrow's omelet. Now, simple chopping is the next thing to do. While I do this, we'll talk a little bit about how we're going to make sure that it's the oysters that win this battle. When we grow microorganisms in the laboratory, we talk about the difference between a rich medium versus a selective medium. A rich medium has all of the nutrients for a class of organisms to grow, and they all can grow. So the rich medium for fungi is what's called potato dextrose agar, literally made from potatoes. Very starchy, very full of food, and the vast majority of fungi can grow on it quite vigorously. The problem is, if you use that, you have to be very, very, very sterile. Not just pasteurization. Everything needs autoclaved, and even these individual pieces, I would need to put in a mild detergent and a weak bleach solution to surface sterilize them to make sure that everything around it other than the oyster mushroom is gone. And it's still risky because mushrooms, when they grow, often incorporate little bits of their environment into that twisted network of mycelium. So it's very difficult. Takes a lot of training, a lot of practice to grow them successfully on rich medium. So we use selective medium. We use something with almost no food in it. These are wood rot fungi, and this method will only work for wood rot fungi. All three of these are. So they have a biochemistry which uses peroxide to blast apart cellulose and lignin molecules and derive energy from those sugars. Not all fungi have this. Therefore, we greatly reduce the number of organisms that are able to grow on the cardboard to slightly, to just these primary decomposers. And they will grow on it very vigorously. There are very few things that oyster mushrooms cannot digest. They're amazing. They can digest crude oil. They can digest just pure cellulose. If you take a potato, oyster mushroom can digest it. But it's going to grow bacteria and mold far faster than it's going to grow the oyster mushroom. This, very few things can grow on. So it's a selective medium. And that's why, that's the trick I mentioned, that lets us get away with not needing a full lab. But again, this only works for primary decomposers. You cannot do this with any of the mycorrhizal fungi, such as boletes, chanterelles, a lot of those earth-growing mushrooms are mycorrhizal, especially ectomycorrhizal. There's a few weird ones that we're not quite sure what they're doing. Mushrooms tend to be kind of end up being rather hard to study. But the mushrooms that grow out of the side of a dead tree are all primary decomposers, and they cooperate very nicely with this method. So we have our selective medium. We have our diced mushrooms. We need a bag to contain this. Nice, clean, new Ziploc bag. Do not use a reused or washed bag for this. This is one of those times where you need a single-use plastic. Get that out of the way. So, we take a piece of cardboard. It's cooled down enough. I can just do this with my fingers, which is good because we don't want to burn our good mushroom to death. Okay. Now, this is some heavy packaging, double corrugated cardboard, which is nice for this. And you can see it's completely fallen apart. This is, you can tell from how it feels, this is starch paste cardboard. Most is. Sometimes you'll have methyl cellulose paste. You can kind of tell the difference because it's a little slimier and stringier. The starch, when you do this, kind of largely soaks in so it doesn't string up or glop. So that's a little extra food for our critters, but still the process of making This cardboard, making the paper pulp itself, removes the overwhelming majority of the nutrients within the original wood. Okay. Now, we have our two sheets, two corrugations. If you don't have double corrugated cardboard, use single corrugated cardboard. Totally fine. Just use two pieces of it. What we're going to do is we're going to take a few of these little chips. All we're going to do is sprinkle them on the inside. This is a dead simple method. And then we're going to close this little sandwich, corrugation to corrugation. And I like to put the corrugations perpendicular to each other. It helps promote airflow. And then this sandwich simply goes into the bag. Okay. And then we repeat until we have run out of diced mushroom. Now, fungi can turn different aspects of their biochemistry on and off. So, when they go from whatever they were growing on, reaching out trying to find a new food source, finding the cardboard that I'm currently giving them, they will touch it, and they will kind of, not with literal thought, of course, but ask the question, what's in here, and what enzymes do I need to break it down? So they'll just sit there in light contact with it. Usually it takes a few days. Just kind of sit there and feel it out, see what's going on. Then they will expand rapidly. Once they have just figured out what their new food supply is, they will expand very, very rapidly because they have now turned on the enzymes they need to digest it. So you won't see anything for a few days. I like to separate these layers with something they can't digest, otherwise they will glue all of the cardboard together and you will never get them apart. So in goes some freezer paper. The first batch I used tin foil, but I ran out. So we're switching. Totally fine. Anyhow, they'll turn on the enzymes that they need to digest the cardboard and then explode through your medium. So you'll see nothing, 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 everything. At that point, you can take this and use it to start a new culture, or you can apply it to, add it to a medium that you want them to fill and propagate in to grow for food. We are going to do that. It is important when you're growing these that this one's a little rectangular. These are parallel. It'll be fine. They're pretty flexible. Not hard to get along with. It is important when if you're going to try and maintain a culture that you switch the medium every so often. If they aren't continually exposed to new food sources, they will establish a fixed biochemistry. Those genes that are turned off will get turned hard off, and the genes that are turned on will get turned hard on. And after that happens, it becomes much more difficult for them to adapt to a new food source. Also, they lose vigor when this happens. So your culture will get weaker and weaker and weaker, and will have a harder and harder and harder time colonizing the medium with which you want to actually produce your mushrooms for food. So we'll take these, once they grow, we'll inoculate them onto some logs by sticking 2 logs end to end, putting it in the cleft. We'll do that in a couple weeks, and we'll have a video on that as well. And then we will grow them out. When that is finished, I only got half the sheet. And we get mushrooms, then I can take them, again, take the food mushrooms, take a subset, go to cardboard, and then go back to the log. So they will keep switching, cardboard, log, cardboard, log, cardboard, log. You can also use straw, you can use coffee grounds, you can use all sorts of things to do this. It doesn't have to be cardboard. But all of those things have much more nutrition in them, so they mold much faster. So it ends up that the porous medium ends up becoming the easiest to use because the mushrooms that you want are more likely to win the race with the molds. Notice how I phrased that. There is a chance that some of these will mold faster than they grow fungi. This method is not 100%. We're doing everything we can to weight the odds in our favor, but it's not 100%. It's not perfect. If you want perfect, you need a lot of expensive equipment. This is good, not perfect. So the last thing that we're going to do to weight the odds in our favor, once I have completed all of these fungus sandwiches, is grow them in the fridge. The wood rot fungi, oysters, maitake, shiitake, especially shiitake, lion's mane, these all grow very well in low temperature, much better, much faster than the molds can. There are molds that can digest cellulose directly. Mold can grow on cardboard. But the molds grow best at high temperatures. The oyster mushroom. Okay, apologies again. We had the second technical glitch. While that was being fixed, I did finish the last stack that I was working on. So this is a finished bag. Separated, multiple layers, separated by something they can't fully occupy, so we can peel these apart and use them easier. These will now go into the refrigerator. I was starting to say before pre-glitch that if I leave this out at room temperature, the mold will grow, the oysters will grow, the mold will grow faster. If I put this in the fridge, the oysters will have an easier chance of outgrowing the mold. Some of these will fail. It's guaranteed. There's too much around. Even with the absolute perfect technique, you still have high failure rates when you're working with this kind of fungi. So if one of these bags gets moldy, chuck it out. Don't try to save it. You can't. Mold spores are so aggressive. By the time you see that there is mold, it is too late to do anything about it. Chuck it out. Go to the store. Spend another $3 on another batch of mushrooms. Start over. It'll be fine. You will lose some cultures. It's just part of the exercise. That concludes this little lesson. I am going to now get rid of this dirtied up cutting board, wash my hands, re-clean the table, and do my third species. So while I do that, I hope you have a wonderful day, and I hope you will like, share, and subscribe, and I will see you on the next video.